And now we are continuing with the next workshop, Semantic Web and Blockchain. The semantic web emerged from the need to make data and services on the World Wide Web interoperable and highly trusted. While semantic web relies greatly on shared schemata, the blockchains are shared databases with strict consensus mechanisms controlling the generations of new transactions. The goal of both is to provide trustworthiness of the information. This workshop explores the relationships among the two, today major concepts of the internet. And may I welcome our moderator, Dr. Vlado Stankowski from the University of Ljubljana, Faculty of Computer and Information Science. The stage is yours.
Thank you very much. It's a great pleasure for me to have this workshop at the European Blockchain Week. We have compiled a very interesting program, I believe, that is about the semantic web and blockchains and how these two types of technologies and standards and complex approaches to sharing information and knowledge in the web can combine between each other. So we have a number of distinguished speakers today. So first on the stage, I would like to invite Mirko Lorenz, who is the coordinator of the next generation internet project called Trublo. So Mirko, please, the floor is yours.
Well, thank you very much, Vlado. Hello to everyone in Slovenia. I would like to make a brief connection. I'm a representative of another EU project called Trublo. And in Trublo, we kind of look at a neighboring area to the semantic web, trusted content using future blockchains. And to that end, we're using the mechanism of cascade funding, meaning that we're giving away relatively small fundings for early stage ideas to teams across Europe. We are now in the status that we have conducted 2 open calls. The open call just ended. It is now looked at by experts. For the first open call, which happened earlier this year, we already have selected 10 projects. And that is basically what I very, very shortly right now, to not block too much time away, would like to talk about. I think with regard to blockchain beyond crypto, we are on the right direction in Europe, looking for alternative ways in the context of next generation internet, an internet that serves many of society's purposes, many of the individual purposes. And there's much to argue with today because we're dependent on a monoculture of commercial projects, usually from the US. And that is simply not enough. I'm not criticizing the success of others, but I would like to open the door to alternative approaches. And what I would briefly like to talk about right now is the diversity and the interesting depths of the project that we selected in the first call. For example, I mean, what is all connected with trusted content on future blockchains? Example, we have a team from Serbia that wants to use blockchain to have better aviation data. We say that today's aviation data is at times they are experts from this community, from this domain. And if we would store data from planes, from airports, from airlines on a blockchain, how would the system be more reliable and more trustable? How can we optimize and connect to things like delivery and sourcing chains? Another example is a team looking into trustable data and information for marketing purposes. How clear is it that the hotel that we are looking at is actually, has 5-star reviews from everyone? How many of these reviews are potentially not even true? That is another issue with products and reviews. So everything where money and a lot of movement is involved, we need to kind of expect that there will be only some free agents or black riders who are trying to game the system. And that isn't just another example. And at this point, I would like to stop, to open the discussion to a wider thing. This pushing forward of small ideas towards sustainability is the big challenge ahead for the next 3, 4, 5 years. And it's going on now, and that is my main message, and I'm happy to be here. Vlado?
Thank you very much, Mirko. We are collecting questions. So if there are any questions, you can also type them or ask them anytime during this session. So we can continue with the next presentation, and that's the one of the coordinator of the ONTOCHAIN project, Madame Caroline Barel. So please, the floor is yours.
Thank you, Vlado. I hope you can see all my screen. And I would like to say hello to all of you. So ONTOCHAIN is a new software ecosystem for traceable and transparent ontological knowledge. And today we are going to see how it reflects both semantic web and blockchain. So as aforementioned by Mirko, we are also a project, a European project funded by the European Commission, and we are also part of the European Next Generation initiative. This project was launched in September 2020 to empower innovators and researchers through 3 open calls to develop blockchain-based knowledge management solution that will be at the end part of an overall software ecosystem for better share of knowledge and value. So actually, as the previous project, we are in our second round of open call. Open call 1 was dedicated to the design phase. We have first engaged 17 projects there, and we have kept 7 that we consider were fitting the most to our initial architecture. So actually they are finalizing this phase, and we have had already several outcomes. We will see that a little bit later. And we just close our open call 2, which is about implementing this design specification and thus to let's say to build the foundation of the ecosystem. In open call 3, we will be more oriented on the deployment of this ecosystem. So we are a project of 7 core partners with expertise in, among other, semantic web, linked data, ontology engineering, blockchain interoperability, knowledge management, distributed and decentralized computing, business model for trust knowledge, and so forth. We are spread, as you can see, all around Europe with F6S in Ireland, European Dynamics in Luxembourg, IExec in France, and Semantic in Italy, the University of Ljubljana here in Slovenia, the Chamber of Commerce, the Greek and German Chamber of Commerce in Greece, and the University of Economic and Business of Athens in Greece. So what we can observe today is that there is many challenges for the internet. In fact, the success of the internet lie in free speech, open innovation, and interoperability, However, there is a growing concern that openness, trustworthiness, privacy, and security are being threatened by the quest for high performance and profit on one hand. We can also see multiple threats when people interact with online services, such as unknown provenance of information, anonymity in favor of criminal activities, personal privacy violation, and personal data exploitation, bias in AI algorithms, no fair reward for quality contribution, spread of fake news, centralization of power, and this existing problem of misuse of information can soon achieve even more dangerous level. So, in fact, the internet should be more resilient, trustworthy, and sustainable. And how do we want to approach this in ONTOCHAIN? By leveraging semantic web and blockchain asset to build as a distinct added value for the next generation internet, trustworthy data and service exchange, and trustworthy content and media. So you all know, I believe, the asset of semantic web, which is a set of technologies that focus on data, how they are described, modeled, and linked. And on the other hand, we have the blockchain, which is a technology that aims at storing data and shares such data among a set of peers who validate the content without the intervention of third-party services. And us, in ONTOCHAIN, we believe that we can leverage these two technologies in order to achieve trustworthiness by standardized storage and ontology, which are shared conceptualization on one hand, and on the other hand, by the decentralization and data immutability, namely share ledger. So this is how we want to contribute. Actually, here is our ONTOCHAIN framework. So we have already some core protocol and application protocol that are materialized here in green, and that are outcomes of the first open call. So dealing namely with authorization, certification, identity management, decentralized storage, reputable model, multi-source identity verification, data provenance API. And in the open call 2, we will focus more on secure data exchange, semantic matchmaking, decentralized autonomous organization, cross-chain transaction, ONTOCHAIN API gateway. So all this, of course, we will follow the frame, distribute ledger, ontology, and application, who will be at the end part of the open call 3. Today we have here some of our third party, namely GraphChain from Macolab, the project POC4COMMERCE from the University of Catania. We have also Dart from the University of Padova, KnowledgeX, and EB. So you will hear, if not already done, from them. So actually, the 7 final project of call 1 has achieved some very good outcome, and their main results are around horizontal SDK, vertical microservices, semantic database ontology. And they also support some feature like SSI, authorship and reuse, data privacy, reputation management, integration of semantic in blockchain, and e-commerce ontology. As a conclusion, our future work now is to define the ONTOCHAIN architecture in more depth with detailed API among the different component and implementation detail. We have also to demonstrate a prototype implementation of exemplary distributed application enabled by the proposed platform. And at the end, we will deliver this complete software ecosystem and a novel, ambitious DLT application in areas such as trustworthy web and social media, trustworthy crowdsourcing, trustworthy service orchestration, decentralized and unsupervised online social network, and so forth. We will be successful, and this is our intention. Sorry, if this ecosystem of innovative application will be widely and sustainably adopted by vital sector of the European economy. So that's it for me. Thank you very much, and I would like to also acknowledge all the ONTOCHAIN partners, as well as the third party that are already involved in our project. So Vlado, if there is any question.
It's a very interesting presentation. So maybe we can just collect questions and maybe ask them in the end, since time is short. So I would like to invite Tomasz Wozniak, who is representing the Macolab company that has operations in the States and in Europe in the blockchain domain. So please, with your presentation, go on.
Thank you very much. Okay, I must say it's a great pleasure for me to be here, especially in Ljubljana. So I would like to say and present our GraphChain projects. So before I will explain what is GraphChain, I would like to say a few words. What was the principle? So why we decided to build this this project? So we can say that the principle was the proposal. So as the result of our analysis, we have proposed the architecture based on blockchain semantic data model, and these were the principles. And why RDF? Well, we've made a survey and we tried to ask participants, and we decided that at this moment, RDF offers explicit semantics and easy to use serialization. But of course, we are thinking about the future as well. And in the future, we are planning to use also property graphs for our solution, like Neo4j and labeled property graphs. So what is GraphChain? Well, we may say that GraphChain is a distributed graph database secured by blockchain. But in other words, GraphChain, it is the trusted, irrefutable, confirmable, and highly available dissemination of knowledge represented by semantic ontologies and knowledge graphs. So this is the proper definition of our solution. And at this moment, we are building a child chain based on 4 GraphChain ontonodes. And I will say a few words about each of these components in a more technical way, but not too long, of course. So each ontonode consists of a blockchain node based on Besu Ethereum client, and this is done in Java. A method of storing hashes in blockchain, so smart contract design. Streamlining of installation and configuration of blockchain nodes through containerization technology Docker, calculating hash of the state of the blockchain and writing proposal for smart contract for parent chain for storing this hash in layer 2. And a blockchain node will be integrated with graph database Blaze Graph on the bottom of our drawing, according to accessing triple store data from smart contract without using oracles. Another component is Blaze Graph, so it's ONTOPod. We call this ONTOPod. It's a triple store, and we are storing RDF data in Blaze Graph triple store there, and we are modifying iHash algorithm to include RDF star extension data model. And there is synchronization between these two modules, so between Besu clients and Blaze Graph. And the third the third component is ONTOCHAIN. We call this ONTOCHAIN is API REST. All these components, this is important, all these components, so Besu client, Blaze Graph triple star, and our own modules will be containerized in separate Docker images, and GraphChain as the whole will be created using Docker Compose tool. So we are finishing right now this ONTONODE development, and now we are building a portal called ONTOHub. And this will be a central access point for all ONTOCHAIN projects creating and consuming ontologies. But in our vision for the future, for the layer 2, we see many child chains, and one of them would be ONTOHub child chain connected to parent chain managed by blockchain. So for example, other projects from ONTOCHAIN like Copyrightly, like POC4COMMERCE, and ONTOHub, of course, as well, are child chains. Now a few words about API. Our REST API is the main method of interaction with ONTONODE, but we are sure that this is not very intuitive. So we have prepared a very short web GUI demo to present the main functionalities. So I hope that this will be more interesting. Just to show how it works, we are presenting here a new graph named CRG3. And this content was taken from one of the partners from Copyrightly, so you can see it on the screen. And we choose the format JSON-LD, and we just click upload. What's happening on the log? You can see that there is a new list with number 57, and this corresponds to the content of the smart contract with metadata about that particular graph. We can go now to the download tab, where we can download the graph based on its URI. So we select the format. Of course, it doesn't have to be the same input as Turtle here, and we enter the graph URI C3 and we click find. We get the result, and there is a list of versions, but we will come back to this in a moment. And of course, that the fact that the graph can be read from the same node in which it was saved is nothing new. So we will go to the second tab right now, and we will have analogous interface, and we are doing exactly the same thing. And as you can see, the result is the same as in the case of the first node. So the synchronization was successful. And now we will move on to the versioning, because our graph chain stores previous versions of graphs with possible additions, and now we will do that. So we go to the first node, we click upload, and we repeat exactly the same steps. But now we are going to modify the graph. So instead of Clark Kent, we are changing the name into Lois Lane, and we upload. As you can see on the log on the right side, the synchronization was successful, and we have new entry with number 58. I hope you can see it. So we will go to the second node, and we click find again. And now you can see that there are two versions of the graph. So we can switch between them and select, and we can see that there is Clark Kent and Lois Lane. So two versions of the graph. We go now again to the upload, and we are going to upload the new graph, CRG4. And we paste new data, also the courtesy of one of our partners of Copyrightly, and we click upload. And there is another log with number 59 on the list. So what we are going to do now, we will go back to node number 1. in a moment. And we can download the data. So we will download this graph, CRG4. And now you can see that synchronization works in every direction. So that's all about our demo. Thank you very much for your attention. And of course, if you have any questions, please do not hesitate to ask. Thank you.
Thank you very much, Tomasz, for this interesting demo presentation. And now I would like to ask if the audience, if they have any questions, please also consider typing them in the chat, or you can, of course, ask them in the end, depending on the time that we have left. So the next in these presentations is Daniele Francesco Santamaria, who comes from the University of Catania, and he's going to present a use case related to agriculture. So please, Daniele.
Yeah. Thank you, Vlado. Good morning. Allow me to share my screen. I hope you can see now. So I'm here to talk about semantic blockchain, but let me explain what semantic blockchain is. Semantic blockchain is a vision of blockchains where transactions are enriched with metadata, in particular with the semantic metadata, and specifically metadata adopting the semantic web technologies, which are right now the most important technologies for semantic metadata. But why we need to talk about semantic blockchains? Semantic blockchains are very important because they facilitate the understanding of smart contracts running on the blockchains, enabling interlinking of smart contract between the two distinct blockchains and with data outside the blockchain itself. And I think that is most important. Semantic blockchains enables automatic discovery of smart contracts, and that implies that users are able to find everything inside the blockchain. For example, what, when, and how specific assets and specific tokens such as NFTs are being exchanged and generated or burned during their lifespan. Of course, the idea of semantic blockchain is not new. We are not inventing the wheel, but if you look at the past, the idea of semantic blockchain is quite limited to annotated just information just about blockchain transaction, but we need to go beyond those limitations because we need to really reach a semantic blockchain in the sense that we need to enable user and application to automatically discover everything inside the smart contract, inside the transaction on the blockchain. So this is why POC4COMMERCE has been founded by the ONTOCHAIN consortium. And POC4COMMERCE was born with a specific and clear and, in my opinion, easy goal that is to provide a consistent, unambiguous, and shared semantic model, not only for the ONTOCHAIN ecosystem, and in particular to the commerce domain, but for everything that is enabled to run on the blockchain. Now, how POC4COMMERCE works, basically we just deployed an ontological stack consisted of three main ontologies, namely OCFound, OCCommerce, and OCEthereum, which covers a specific domain, but we are going to see in a moment. This ontological stack describes everything around the on-chain ecosystem, for example, participant, actors in the commercial, specifically in the commercial domain, but again, I repeat, not limited to the commercial domain. The ontological stack also describes digital and physical assets, supply chains, including distribution, pricing mechanism, selling mechanism, payment systems, and so on. And of course, POC4COMMERCE ontological stack also describes blockchains, smart contracts running on the blockchain, in particular on the Ethereum blockchain, and everything that is tradable within the blockchain, such as fungible tokens, non-fungible tokens, and also semi-fungible tokens. But of course, we just don't describe smart contracts and tokens. We also describe actions performed on the blockchains. So we are able to describe everything everything included inside our transactions. And that I think that this is the most important. But ontologies are not sufficient to provide, to deliver a real semantic blockchain, because ontologies are not sufficient at all. And for this reason, we are implementing we are in the final stage of deploying a semantic search engine that enables users and applications to probe the blockchain and the data inside of the blockchain. For example, goods, products, and services on the blockchain, of course, meeting the user requirements. So these three ontologies, of course, describes everything we want to describe. But why we need those three ontologies? Because we need to answer to some important questions, such as, please find me a smart contract trading apples. So you need to find all the smart contracts deployed on a specific, on one or more different blockchains that allows you to find NFT about agricultural food, in particular about apples. So this is sounds quite easy to understand, but how all of these things work together. So this is our vision. This is our use case. Customers and service and product providers work together to describe everything they want to put on the blockchain, and not only on the blockchain. So, for example, our Apple provider just deploys a smart contract and provide a description, semantic description, using our ontological stack on our semantic knowledge base. So user just find the smart contracts and all the tokens exchanged, burned, or minted within this smart contract. So you can find everything he desires. For example, specific batch of apple produced in Italy or wherever he wants. And thanks to the semantic description, our search engine is enabled to start the purchase. So this is our vision. This is what we are doing, thanks to the precious mentoring of the ONTOCHAIN consortium. And before I leave, before the final greetings, please allow me to share some thoughts about the future. So about the future of semantic blockchain. I think that the semantic blockchain is a real important thing for trustworthiness and automatization of the blockchain. But for the very next future, I think that the next step is to enable blockchain with automatic metadata mechanism for the transaction. So where semantic data are embedded within the transaction and are part of the validation mechanism. But that is all just my opinion. So the discussion is open. I think that I can leave here. Thank you very much for your attention.
Thank you very much, Daniela,
Thank you
for your
brother.
enlightening talk on foundational basis. I mean, this is going beyond existing technologies in showing the scope of what can happen in very near future in the domain of integration of blockchains with the semantic web. So there are many applications we talk in this forum that are let's say, having some limited impact in specific domains, in specific applications, but in the future, there could be even wider and stronger impact of these technologies in the practically every sphere of human life. So the next speaker here is, and the final one, comes from the University of Padua. In Italy, they have been working in the domain of decentralized oracles, which we know they are very important aspect of the integration between the untrusted world of the physical world and the internet as we know it, and the trusted world of blockchains. So let's, please, the floor is yours.
So, hello, I'm Alessandro Brigente from the University of Padua, and thank you for the invitation for today. And let me share the screen. So, today I'm going to talk to you about the DART project, so the distributed oracle network that we designed. And so the very first thing to know about off-chain data is that there's no practical way to infer the veracity of the data, so that it's not like data which is generated inside the blockchain for which we can use a consensus algorithm to acknowledge the fact that the data is correct. So we need an interface between the blockchain world and the off-chain world, the physical world. And this interconnection is managed by devices called oracles. In particular, if we want to enforce the liveness of the system, enforce the security of the system, we can use multiple oracles in what is then called as the distributed oracle network. So distributed oracle network provides a solution to create an interface to collect physical world data and to pass it to the blockchain. The problem with the current solutions for off-chain knowledge management is the fact that data that is passed to the blockchain is deemed as true. So there's no reliability value associated with the data. And this is particularly, so this is a problem in case of attacks towards the distributed oracle network, where we can think about multiple devices agreeing on a false value and reporting it to the blockchain. And the blockchain will, however, think that this is the true value, but it's instead the value that has been maliciously generated. So with DART, we provide a modular solution for reliability-aware management of the off-chain world. In this figure, we see the three-layer architecture of DART. So at level 1, we have the blockchain which is equipped with a smart contract that polls the off-chain world to retrieve data and to execute actions based on this data. So for instance, let's think about the smart contracts that whose actions are triggered by a certain temperature value, for instance. And so the smart contract needs a way to collect this temperature value to communicate with the device that is measuring and reporting the temperature value. So the second level, we have the distributed oracle network, which is composed by all the devices that we say that are the interface between the blockchain and the off-chain world. And at the third level, instead, we have sources. Sources might be any type of source, being them IoT devices, being them user, them camera, cloud, whatever source that might collect or generate data. and reported to the distributed Oracle network. In this figure, we see the architecture with a finer grain. What's very important in this figure is the architecture of the distributed Oracle network, where we see two types of oracles. So on the right side, we see the oracles as their basic definition, so devices that are connected to sources and report data. Whereas on the left side, we see the aggregator oracle. The role of the aggregator oracle is to receive inputs from all the other oracles and to infer the veracity of the data reported by the oracles themselves. Why do we have this distinction? This is there because we want to be sure about the veracity of the data. So we add a security layer given by the aggregator oracle. So a first check will be performed by the oracle themselves, and a second check by the aggregator oracle, which then is in charge to report the value to the smart contract in the blockchain. On the right side, the most right side of the figure, we see the sources. So to enforce the liveness of the system, we envision two types of sources. Fixed sources, which are always connected to the network, are there from the beginning of time, from the deployment, and will be there up to the end of the system. And then we have the second class of sources, which are causal sources. And these sources instead are there for a limited amount of time. So let's think, for instance, of a crowdsourcing model where we have that users might report data to the oracles. These users will be connected to the oracles and will be there reporting data just for a limited amount of time. So why this is good? This is good because an attacker may not be able to predict which kind of causal sources will be there. So there's no way for an attacker to predict that tomorrow I am going to connect to the oracle, for instance. So there's no way it can the attacker can prevent me from connecting to the oracle and prevent me to report correct data to the oracles. Also, connection between oracles and sources are casual for the very same reason. We don't want an attacker to be able to predict links and jeopardize the security of these links. Then there's the problem on how to actually infer if the data reported to the blockchain is actually correct. So what we design is the truth discovery algorithm, which assesses the veracity of the collected information. The most important thing about truth discovery is that it does not depend on the type of data that sources are generating or oracles are connecting. What I mean is that the very same algorithm works for binary data, for time series data, so it does not depend on the type of data. What it does is exploit the space and time correlation that might be there for data. So for instance, let's think of an open space where we have multiple IoT data measuring, again, temperature, and we can safely assume that close by devices measure temperature values which are correlated in time, correlated in space. And instead, we can also think about time correlation in the sense that the data reported by the very same source might be correlated in time due to some physical process that's there. And again, looking at the figure that we had before, we had the aggregator oracle and the oracles. And this will implement two levels of truth discovery. So each oracle will implement the truth discovery algorithm, and the aggregator oracle will itself use this truth discovery algorithm. The most important thing here is that all sources and oracles are assigned an identity, and this identity is also correlated with how much we trust these sources, how much we trust the oracles based on how they behave in time. So fundamentally, how much correct data they reported in time. So in here, we look at what happens when the distributed Oracle network is under attack. So again, we consider the collusion attack where multiple reporters agree on a false value to report to the blockchain. And we here compare the majority voting scheme, which in a nutshell is a scheme that decides that the true value is the most reported one. So let's say that we have 4 sources, 3 of them are reporting value 1, the 4th one is reporting value 2. Despite of the fact that 2 is the truth value, is most of the sources reported value 1. The majority voting scheme will think that 1 is the correct value. So in this figure, we see what happens to the precision of the the algorithm reporting data to the blockchain when the number of colluding nodes are increasing. And we see that the truth discovery has higher precision than majority vote. So this means that the truth discovery is a viable and effective algorithm to assess the veracity of data and to report correct data to the blockchain, or at least data with an associated veracity indicator. So what are the next steps? We are currently working on the implementation of a testbed to validate both the truth discovery framework and our model for fixed and causal sources. And the important thing here is to investigate the trade-off between the scalability and reliability. As I was mentioning before, we have multiple levels of truth discovery. We can add even further layers of truth discovery. But what the problem here will be that multiple levels will require multiple time, additional time for operation, which might be an overhead. So depending on the application, we might want data in a fast fashion, or we want data in the most possible reliable fashion. So there's a trade-off between these two indicators that should be investigated. The last thing is to investigate the privacy guarantees. So for instance, let's think about the causal sources and causal sources in a crowdsourcing model. Maybe users want to report data, but they do not want to disclose private or sensitive information. So we want to be able to guarantee the security of the data, the veracity of the data, while at the same time ensuring the privacy of the users. And again, there's a trade-off between these two indicators that shall be investigated. Thank you for listening, and thanks again for having the University of Padua here. And of course, if you have any question, I'm glad to ask.
So thank you very much, Alessandro. I think also Tomasz is here in person at the event. So if there are any questions from the audience, we would be really happy now to discuss. We have 10 minutes of time. We're running at strict Swiss type of time. So please, from the audience, any question? You can just speak. So the question is, why is there a residual 15% of false positives if no bad nodes, 0% on the chart on the horizontal axis are assumed? This is a very difficult question, very technical one.
Yeah, so, okay, why is there the 15%? Because I didn't explain all the details about the truth discovery algorithm. The point is that it has a transitory phase where we need to first assess the reliability of sources. And unfortunately, the truth discovery is not super effective in this transitory phase. And although we might have the 0% of bad nodes, still there's a phase where we need to understand how much we can trust the different entities. And in the data that we have here, there's a noise model added on top, which causes the precision to be lower than 100% in the transitory phase. So the 85% we see in the figure is accounting also for this transitory phase. Is an average, basically on a larger time period.
The answer, that's really great academic answer. Actually, thanks to all the speakers, because we had 5 of them, so you can direct questions to any of the speakers of this workshop. So, okay, so there is a question here, great work by ONTOCHAIN. I would like to briefly discuss, okay, the economics business aspects. How we can make these EU approaches sustainable. Okay, so maybe we can give the view first of Caroline and then maybe Mirko.
Thank you, Vlado. I believe that we have in the panel we have here Thanasis Papaioannou that can better explain the subject. So I don't know if we can leave him the floor.
Yes, okay. So we have a related presentation in the next session regarding the sustainability of the ONTOCHAIN platform, but briefly I can mention that it's a very complicated problem where you have actually to make sure that all entities involved into the ecosystem are compensated so that all costs are covered. So in order to create a win-win situation, you have to take into account the costs of all individual stakeholders into the system, including nodes, software developers, individual SMEs that are participating, electricity bills, networking fees, etc., all costs by all players, and distribute the wealth that comes into the system. And the only way that the wealth comes into the system is from the users of distributed applications, and of course from distributed application providers. And then this wealth is distributed among the players into the system so that everybody at least covers the costs and is profitable. Now, there are several kind of goals that can be followed here, like egalitarian maximization or social welfare maximization or profit maximization. I will not enter into that level of detail, but you see that you get the picture that everybody has to be at least to have at least positive net benefit in order for the whole ecosystem to be sustainable. That's what I have to say for this right now.
Thank you, Thanasis. And how about from Mirko's side, from the Trublo project?
Yeah, thank you. Well, in Trublo, beyond the technical development, we have a system of support service for all projects. First of all, in collaboration with Alastria, which is a Spanish not-for-profit association providing blockchain resources. We help them to actually experiment in scaling and implementing their smart contracts and projects. Secondly, and I think that is something that will be discussed, should be discussed more intensely, we are supporting them with business development coaching. We have a mentoring project where the focus is on how can you combine all this great work by scientists and developers towards product fit. Product fit meaning that you have an actual chance to have the first 3 clients. And we're not talking about thousands of clients at the very beginning, but is there a demand for the specific solutions that we are providing? And that is something that is not easy to organize, because you have to bring together highly technical and scientific people with people coming from the business domain. And as I think we all agree that blockchain is an early technology, it's a very promising field, but it's challenging. It's not easy to understand for, say, people who want to sell something in the market. And that is an evolution that is ahead of us. That is my contribution.
Thank you. Maybe if you like to say something about it.
Yes, well, thinking how to answer this question, because I think this question is really very difficult and you need to take deep thinking, deep analysis. I can say that only from our GraphChain perspective, we are more oriented towards the business value, which is a knowledge, in fact, because we are working with different graphs, different knowledge graphs. So for us as the business is the business of knowledge management in the future. So maybe for scientific research as well, for different purposes, but we are totally open to different business models for tokenization as well, for distribution of knowledge in blockchain, and we are agnostic towards this. So this is the answer of our perspective.
Thank you, Tomasz. So maybe as a conclusion, there is quite a lot of value in the information and knowledge. Yes. And the value is even better if we can make this information and knowledge trustworthy, right? And also verifiable and used in different contexts, and also serving the needs of the people. which is actually the goal of these programs of the European Commission to build a more human-centered internet. So I would like at this point to just thank all the speakers. I think maybe the number of participants will double in the next workshop because it is about NFTs. Thank you very much again, and I look forward to the next workshop in 2 minutes from now. Thank you, bye.
Thank you, bye.